Hello everybody, welcome to Chemistry 112. This is lab number 6. What we're doing today is the plop plop fizz fizz reaction. So in the plop plop fizz fizz reaction, we're going to be looking at the concept of limiting reagent. Limiting reagent is when we do a chemical reaction and we're looking at the stoichiometric amounts of the two different reactants. And oftentimes there is one reactant that will run out before the other reactant. And so when that reactant is all gone, the reaction stops. There's no more reactant for it to continue. So that one reactant that runs out first is called the limiting reactant. It limits the amount of product that can be produced. So what we're going to do today is we're going to look at Alka-Seltzer, which is an over-the-counter medication. Usually they contain some aspirin, which is acetyl salicylic acid, citric acid, as well as sodium bicarbonate as their active ingredients. So in the old days, you would take Alka-Seltzer and you would dissolve it in water, and then you would drink the water that had the dissolved Alka-Seltzer in it. In this reaction, when you place the Alka-Seltzer tablet in water, you get an acid-base reaction. And in that acid-base reaction between the acid and the base, you get the generation of carbon dioxide. And we'll be able to see that by seeing the bubbles, right? So that fizzing part of the reaction is the fizzing of the carbon dioxide bubbles. So we are going to look at that reaction, and what we're going to do is we're going to change the amount of acid present in each of these chemical reactions. So we're going to mix a certain amount of acid with one of the Alka-Seltzer tablets and then measure to see how much carbon dioxide was produced. And we're going to look at the data, so we'll have our data table here. And so you can see we're going to repeat this experiment a total of 8 times, initially starting with all water and no acetic acid, and then ending up at the end with no water and all acetic acid. And in each case, we're going to look at the total mass of the carbon dioxide lost. And from that, then be able to calculate the mass of the sodium bicarbonate in the tablet and what percent of that was actually the sodium bicarbonate. So we'll go ahead and proceed, and we'll be filling out this table as we go along. So thanks very much. All right, I'm here in the lab. I am ready to go. Just wanted you to see that I'm prepped. Gloves, lab coat, safety goggles, and closed-toed shoes, right? If you can see the closed-toed shoes. And so here we are ready to do the lab. So we have our beaker of water, we have our Alka-Seltzer tablet, and we've got our data form, so we're all set. All right, the first experiment, number 1, 0 milliliters of acetic acid, 35 milliliters of water, the mass of the beaker in the liquid 141.298, the mass of the Alka-Seltzer tablet 3.257. And what we're going to do now is we're going to drop the Alka-Seltzer tablet into the beaker of water, and we'll watch it bubble. All right, so this won't be a plop plop fizz fizz, this will just be a plop fizz. Now I am ready to repeat this experiment for the second time. Now in the beaker I have 5 milliliters of acetic acid, 30 milliliters of water, and I am going to add the Alka-Seltzer tablet, the plop fizz, and we will mass that container after it's all done fizzing. I will be showing you the final table once all the data has been collected. This process is just going to be repeated for a total of 8 times, each time varying the amount of acetic acid as well as the amount of vinegar that's present. So there we go. Today's lab is now all done. I have completed all 8 trials of the Alka-Seltzer and the acetic acid. I have that data. I will put it up for you as an Excel spreadsheet, so you'll be able to see all the different values that were collected, the amount of acid, acetic acid, the amount of water, the mass of the tablet, what the mass of everything was before, and what the mass of everything was after. And so that will be available to you to look at the data, figure out what the data means, and determine if there was a limiting reactant in that reaction, and if so, which one. So we will see you later. I'll post more information later. Thanks. Bye.